we've got 2 classes of new material remaining in the semester, today and next Tuesday. Then we have our last quest, right, which covers a little less material than they usually do. It's just going to cover lessons 27 through 30, which is algebraic fractions. Okay? It's going to be on Thursday of next week. Yep. So this is fractions, like just all your regular stuff with fractions, reducing, adding, subtracting, multiplying, and dividing. But instead of having just numbers in the fractions, there could also be x's, right? Or other unknowns, variables. Then we'll have a review class, and then the final exam is the 17th, 10:30 in the morning in this classroom. No? No class is mandatory. I don't take attendance. '27 through 30, yep. Okay, so we're going to continue today working with algebraic fractions, and we're going to learn how to add and subtract them. The demo for today is a little long. Apologize for that. Okay, so let's take a moment to recall how you add and subtract fractions that have like denominators. If I want to add 2/3 plus 5/3, what do? You add the numerators, right? So the numerator is going to be 2 plus 5, and what's my denominator going to be? 3. Yep. So that becomes 7/3. Everybody remembers that? Okay. Adding and subtracting fractions with like denominators works the same way if you have algebraic fractions. If you've got some x's, some expressions that involve a variable, you can do the same thing. If the denominators are the same, you just add the tops or subtract the tops, right? And keep the denominator as it is. Okay, so why don't you take a second and go ahead and try this subtraction problem. So the denominator is 3x plus 4, so that's what's the denominator. And then you just subtract the numerators. Okay, raise your hand if you got 6x squared minus 10x as your numerator. If you got that, you made the most common mistake, okay? So really, what happened is you have to subtract both terms of that numerator, right? So we end up, it helps if you put parentheses around the 2 numerators. So your numerator is going to be 9x squared minus x minus 3x squared minus 9x. And then you have to distribute that negative sign to both terms in the parentheses. So this becomes 9x squared minus x minus 3x squared plus 9x. And then combine your like terms. So 9x squared minus 3x squared is 6x squared. And then you have negative x plus 9x, which is plus 8x over 3x plus 4. And then the last step here is to factor and cancel any common factors. So 6x squared plus 8x, can that factor at all? Anything they have in common? 2x, yeah. 2 goes into both 6 and 8, so 2 is a common factor. And both of those terms have an x in common. So factor out a 2x, and I'd be left with 3x plus 4. My denominator is 3x plus 4. Cancel the common factors, and you just get 2x. Yes? factored before you subtracted? I don't think it would work, no. Yeah, because you want to have distinct terms separated only by addition and subtraction, because the order of operations says that you have to do multiplication before you can add or subtract. So if you factored it apart, before you can add them, you have to multiply them back together, right? So right now they're in their multiplied together state, so you can just do the addition and subtraction. Okay, so that's how we do with common denominators when the denominators are the same. Yeah. Ask that again. So I replaced this numerator with the 2x times 3x plus 4. I factored the GCF from both terms of the numerator. Well, it was already in the denominator. It started out as our denominator, right? And then, so just ignore the denominator for a minute. Just look at 6x squared plus 8x. What's the GCF of 6x squared plus 8x? 2x. So when you factor out a 2x, what's left, when you distribute that 2x to here, 2x times 3x gives you the 6x squared, and 2x times 4 gives you the 8x. So it just happened nicely to work out that it came out to a 3x plus 4, so I could cancel. It doesn't always, right? Something over, yep. You're welcome. Okay, so moving on to how to do addition and subtraction with unlike denominators. So we're going to start with just some numbers again to refresh our memories about how this works. And you may be able to do this in your head much faster than what I'm going to write on the board, but this process is going to work well for the algebraic fractions. So see if you can follow me here. So here's my original problem. 9 over 28 minus 3 over 40 minus 1 over 42. 3 different denominators. Okay. So to get a common denominator, you may have developed a process to do that very quickly in your head over the years that you've been doing math. But when you first learned how to do it, this was the process that we went through. You write out the prime factorization of every number. Okay. So I rewrote 28 as 2 times 2 times 7. Does everybody remember how to do a prime factorization? Like sometimes some people do a factor tree. And you go, okay, what goes into 28? 2. 2 times what is 28? 14. And then you factor that 14 into a 2 times a 7. And then the 2 times 2 times 7. That's called the prime factorization of 28. Remember? Okay, so I replaced 28 with 2 times 2 times 7. Let's do the prime factorization of 40. Okay, so 40 can be rewritten as what times what? 2 times 20, sure. And you can start with anything. You could have started with 9 times 5, right? You can start with any 2 or 10 and 4. Any 2 factors of 40 you can start with. So 2 can't be factored any further because it's prime, so you go to the 20. And that could factor to 2 times 10, sure. And then the 10 can be factored to 2 times 5. All of my numbers at the end of my branches are now prime. So we call that the prime factorization. 2 times 2 times 2 times 5. So I replaced the 40 with a 2 times 2 times 2 times 5. One more, we've got a 42. So let's do this one just a little bit differently. All the others I've started with taking out a 2, which is fine, but I just want you to see that you can do it in other ways. What 2 numbers can I multiply to make 42? 6 and 7. Put a 6 and a 7. 7 is prime, so I can't factor that branch any further, but 6 can factor to 2 times 3. Okay, so 2 times 3 times 7, that's my prime factorization of 42. So you replace the 42 in the last denominator with a 2 times 3 times 7. Okay. And see how I left extra space in all my fractions. So that's going to be a key here. Leave the extra space. Okay. And my next step is to build the lowest common denominator by multiplying each denominator by what it's missing. Okay, so imagine these denominators are like envious people, right? They look at the other fractions around them and they want to have everything the other fractions have, right? It's like keeping up with the Joneses. Okay, so this first fraction has 2 2's and a 7 in its denominator. It looks at the second fraction and goes, that fraction has 3 2's. I need another 2, right? And that fraction has a 5. I need a 5. Okay, so we have to give, it's going to go out and get a 2 and a 5. Right? So if I add a 2 down here, so I do times 2 and times 5. So now the first fraction is equal with the second fraction. But then this first fraction looks at the third fraction and says, that third fraction has some stuff that I want, right? I don't have it and I want it. So what do I have to give to the first fraction so that it has everything the third fraction has? The 3. So I'm also going to put a 3 here. All right, if you multiply the denominator of a fraction by something, if you don't want to change the value of the fraction, you have to also multiply the numerator, right? Because you're just multiplying by 1 then, fancy form of 1. So I'm also going to multiply the numerator by 2 and 5 and 3. And then we do this for every fraction. So the goal is that all the fractions will have the same denominator, right? They're all going to go out and get the things they need so that they're the same as each other. Okay, so this second fraction, it looks at the first fraction and says, well, the first fraction has 3 2's. I have 3 2's, all set with 2's, right? The first fraction has a 5. I have a 5, all set with 5's. But the first fraction now has a 3. First fraction has a 3 and a 7 that I don't have, right? I need a 3 and a 7. So I multiply by 3 and by 7 on the bottom. And then if you multiply on the bottom, you have to multiply by on the top. So now the first and the second fraction are the same. And the third fraction wants to look just like them, so we have to give it what it's missing. So it's only got 1 2. The other 2 fractions have 3 2's, so I got to give it 2 more 2's. It's got a 3, and it's got a 7, so it needs what? A 5. So then you have to do the top also. All right, so we've built the common denominator. We've created the lowest common denominator. So the next step is just to multiply stuff, and you can subtract the fractions. I have that on the next page. Okay. Okay, so our next step is that we could combine them into one numerator, right? So then, since the denominators are all the same, I can just write this as one big fraction over the common denominator, and I just subtract the numerators. Okay. I didn't bother multiplying them together just yet. You can multiply them first or second, doesn't matter. Okay, so 9 times 2 times 5 times 3, that's 270. 3 times 7 times 3 is 63. 1 times 2 times 2 times 5 is 20. Then you do your subtraction. 270 minus 63 minus 20 is 187. Notice I never bothered multiplying the denominator together. Okay. That is to help me when I want to reduce. If I want to reduce the fraction after I've done the subtraction, having the denominator factored will be really helpful. So I leave the denominator all unfactored, all totally factored. So now when I want to reduce, I just have to look at my 187 and do its prime factorization. So I look at 187. That one's kind of hard to do in your head, but it turns out that 11 and 17 are the only 2 numbers you can multiply together to get 187. And they're both prime, so that's its prime factorization. If you didn't know that off the top of your head, you would just start trying prime numbers, right? You just pull up a calculator and you'd go 187. Does 2 go in? Well, I know it can't because it's odd, right? Let's try 3. Nope. 187 divided by the next prime is 5. Nope. 187 divided by 7. Nope. 187 divided by the next prime after 7 is 11. The primes are up on the board over there if you ever forget. So oh, 13, I missed 13, yeah. 187 divided by 13. Nope. So you go 187 divided by 11, yeah, 17. If you could cancel anything on the top and the bottom, yeah, right. Yeah, so in this case, it turns out you can't, right? There are no 11s on the bottom and there are no 17s on the bottom, so there's nothing to cancel. So the answer is just 187 over 840. But sometimes you can cancel things after you've done that factorization. All right, so we're going to use this same process to add and subtract fractions that have variables in them, okay? Algebraic fractions. Okay, so we start out with our addition and subtraction problem, 3 over x squared plus 4x minus 5x minus 1 over x squared plus x minus 12 plus 1 plus x over 2x. 3 different denominators. So rather than doing a factor tree, like a prime factorization with numbers, we factor these things, which we've been working on for about half the semester, right? Factoring algebraic expressions. So you can take x squared plus 4x, right? It's got an x in both terms, so you factor out the GCF of x, and it becomes x times x plus 4. And then the x squared plus x minus 12, it's a trinomial, so you would make a box, right? Or use your own FOIL method or whatever you know how to do. X squared plus x minus 12, and that factors to x plus 4 times x minus 3. Okay, so in the interest of not getting bogged down in the details, I'm not going to do the box out. I'm just telling you that that's how you factor it. And then finally, 2x. Can't factor any further, so you just rewrite it as a 2x. So just like with the numbers, you take each denominator and you factor it as much as you can. Cancel x plus 4 with what? No, the only time you can cancel things is if you have the same thing on the top and the bottom, and they're only separated by the things next to them by multiplication, right? So these are both on the bottom, and they're separated by subtraction, so you can't cancel them. But it would cancel out with 0, right? No. No, when you add fractions, remember, you can't do any addition and subtraction until you have the same denominator. Okay, so my next step is I want to build the common denominator. All the denominators are envious of the other denominators, and they want everything that the other denominators have. Okay, so my first denominator, it's got an x. I find it helpful to put parentheses around every factor so you don't forget any, right? So my first denominator has an x and an x plus 4. Second denominator has an x plus 4 and an x minus 3, right? So this first denominator is looking at the second denominator, and it sees what it has. It goes, oh, you have an x plus 4, I have an x plus 4, right? And then it says, you have an x minus 3, I need one. So we have to give it an x minus 3. And if you put one on the bottom, you got to put one on the top, right? Because then you're just multiplying by a fancy form of 1. All right, and then this first denominator, now it has everything that the second denominator has. So the first denominator now looks to the third fraction, looks at its denominator and says, what do you have that I don't have? I already have an x. First denominator has an x. A 2. The only thing it doesn't have is a 2. So I probably should have put parentheses more strategically here and said that's a 2 and an x, right? You can separate those. You don't have to use the whole 2x just means 2 times x, right? which is 2 times x. All the same thing. Yep. I haven't separated it, I just wrote it a different way. So this one's got a 2 and an x, 2 times x. So this one already has an x, so it just needs a 2, so I put a 2 on the top and the bottom. Nope, it doesn't matter, because multiplication can be done in any order. So yeah, if that might make you feel better, because then it looks the same as the 2x over there. That's fine. Okay, so now we move to the second fraction. So we move to the second fraction, and the second fraction wants everything that the first fraction has in its denominator. So it already has an x plus 4 and an x minus 3, so what's it missing? An x and a 2. Yeah. Oh, there we go. Yeah.
Because it has an x, but it's in the addition and subtraction notes.
Right, right, because we're talking about factors. The word factor means things you multiply together, right? So it needs to have all the same factors.
Oh,
So
okay.
this x plus 4, it matches the x plus 4.
I thought you'd be able to boil it and have like x.
Right. Right, when you multiply them together, if we didn't put an x here, it wouldn't come out the same as that. All right, so if I add an x and a 2 to my denominator here, I have to add an x and a 2 to the numerator also. All right, and then my final fraction has a 2 and an x, so what's it missing? X plus 4 and x minus 3, and you have to put it on the top and the bottom. All right, so now they all have the same denominator. So that means that I can add and subtract them. Right, so I can write this as one big fraction that all has a denominator of x, x plus 4, x minus 3, and 2. Not yet, not yet. It's going to be in our best interest to leave the denominator factored, not multiplied together, until after I've done all my work in the numerator, because then if I want to see if anything cancels, I'm just going to have to refactor again. So my numerator is going to be 3 times x minus 3 times 2 minus 5x minus 1 times x times 2 plus 1 plus x, x plus 4, x minus 3.
You have to FOIL those signs with a negative.
Yep, yep. So my numerator now I'm gonna multiply everything together and combine like terms. Okay, so this is going to take a little bit of attention to detail because there's a lot of arithmetic to do up here, right? So what's 2 times 3? 6. All right, so I have to multiply 6 times x minus 3. So I'm going to get 6x minus 18. Everybody see that? So 6, and then distribute your 6 to your x minus 3. So you get 6x, and then 6 times negative 3 is minus 18. And I'm going to keep parentheses around my results. So then I have minus, and then I'm going to try to multiply these together. X times 2 is just 2x. So it might be helpful, actually above here, I think I might write down my simplifying. Okay. And then here I'm going to rewrite this as 2x times 5x minus 1.
So you don't distribute.
Not, you will. I'm going to do it in the next step. Yeah. This is 2x times 5x minus 1. Okay, so the x times the 2 becomes a 2x, and then you distribute that to 5x minus 1. And so I'm going to get 10x squared minus 2x. And that's why I left the parentheses there, so that I'll remember to distribute that negative later. All right, and then I have plus.
You also distributed at that stage?
Sure. Okay. Yeah. All right, and then this one is going to take a little bit of work to multiply together because it's 3 binomials. So you can use FOIL or lobster claw or a box. Let's see, I'm going to keep this 1 plus x. And then if I multiply those together using whatever method you like, we end up with x squared minus 3x plus 4x is plus x minus 12. So then to multiply 1 plus x times x squared plus x minus 12, you have to distribute both terms of 1 plus x to every term in the second set of parentheses. So start with the 1. Start with the 1 and distribute that 1 to each term in the parentheses after it. So 1 times x squared is x squared. 1 times x is x. And 1 times negative 12 is negative 12. Then you have to do the same thing with the x. Distribute the x to everything. So I get plus x cubed plus x squared minus 12x. You also could have done it with a box, right? You could have had a 2 by 3 box. And you'd put x plus 1, x squared plus x minus 12, and then you'd get all the same terms that I just got here. This is all over, all over our common denominator. Okay, probably 2 more lines I'm going to have to do here. So this last set of parentheses on top, I have some like terms I can combine because I've got an x squared here and an x squared here. I've got x terms here and here, so I can combine those. And maybe I'll distribute that negative like Abby was suggesting. I can do that in this step too. So I'll have 6x minus 18 minus 10x squared. And then I have distribute that negative, so I have minus negative 2x becomes plus 2x. Then I have plus x squared plus x squared is 2x squared. X minus 12x is negative 11x. And then I have an x cubed and a minus 12. Oh my goodness. Okay. Right. Right. Not when you're adding. Yeah. These underlined terms, positive x minus 12x. So that's a plus 1x minus 12x. Like if you have 1 apple and you take away 12 apples, you have negative 11 apples. Right. All right, so now I'm going to combine like terms in the numerator. So let's see, I'm going to circle. My highest power is x cubed. So I've got an x cubed on the top. And then my x squareds, I've got 1 there and 1 there. Negative 10x squared plus 2x squared would be negative 8x squared. And then for x's, I have 6x plus 2x minus 11x. So that's 8x minus 11x is negative 3x. And then for constants, I have negative 18 minus 12, which is minus 30. Correct. Yes. This is not an equation, right? This wasn't something I'm solving for x. So you can tell if you go back to the very beginning, this was my original problem. There's no equal sign anywhere in there, which means that you can't figure out what x is, right? Tuesday, we're going to solve equations that have algebraic fractions. Okay, so this is just a simplified fraction. We just added and subtracted the fractions.
So even if you boil that out, still you have to, I guess, unless you work out perfectly, you can cancel it.
Yeah, if you can factor the top, sometimes you'll be able to cancel something with the bottom. But
unless it was like equal to 8 or something.
Right. Yep.
So that's what we're going to be doing, setting finding x.
On Tuesday, yeah. Yeah. All right. Questions before we do one more example? I know. so sometimes in the demo I try to put like every kind of quirk that a problem can have, I put in one problem so you can see it all at once.
It's really long, but it's like the basic idea.
The basic idea is what we did with numbers, right? The basic idea is exactly what we did with the numbers. So it does take a long time, but the idea is just keep the big picture in mind, right? Got to get the same denominator, add and subtract the numerators. Yeah. Yeah, Amy. Factoring the fractions. Yeah, you're factoring the denominators. Yeah, and then you use those factors to create a least common denominator. Yep. All right, so we'll do one more, okay? So I already did the factoring part for you, so that makes things a little bit easier. Although, maybe I shouldn't. Maybe we should start from scratch. Nah, all right. All right, so here is my original problem, right? I just want to simplify this. This is a subtraction problem. I've got two fractions, I'm subtracting them. So I just rewrote the two fractions with big long fraction bars because I'm going to need to create my LCD. Okay, so I added these long fraction bars. And then I factored the denominators. Okay, so x squared minus x has a GCF. There's an x in both terms, so I factored out an x and it became x times x minus 1. And it can be helpful to put parentheses around that x, help you identify it as a factor. All right, and then this x squared plus 4x minus 5, that gets factored to x minus 1 times x plus 5. Okay, you would use a box or a guess and check method that you like. So that's it. There's just the two fractions this time. Okay, so now I have completely factored both denominators. So now each denominator looks at the other and wants whatever the other one has. So this first one's got an x and an x minus 1, and it looks at the second fraction and it goes, you have two x minus 1s. I need two x minus 1s. Okay, so I have to give this fraction another x minus 1 on the bottom and the top. And then what else is the first fraction coveting of the second fractions? X plus 5. So we got to add an x plus 5 here. All right, and then the second fraction looks at the first fraction. It already has two x minus 1s, just like the first one does now. It already has an x plus 5, like the first one. But what is it missing? And just an x. So I do times an x on the top and the bottom. So now I'm going to write this as one big fraction that has a common denominator. X, x minus 1, x minus 1, x plus 5. And then my numerator is going to be 4 times x minus 1 times x plus 5 minus x minus 7 times x. Of course you could. Yeah. X minus 1 times x minus 1 means x minus 1 squared. Yep. All right, so I'm going to multiply x minus 1 times x plus 5. So now I'm working on just multiplying the numerators. I'm going to multiply, combine like terms, leaving the denominator factored because that might help me in the end if things can cancel. Okay, so 4 times x minus 1 times x plus 5 comes out to x squared plus 5x minus x is plus 4x minus 5 minus x minus 7 times x is x squared minus 7x. And I kept the parentheses there because I'm subtracting and I need to distribute that negative sign. So I'm going to distribute that 4. So I have 4x squared plus 16x minus 20. Distribute that negative sign. So I have minus x squared plus 7x. Combine like terms in the numerator. 4x squared minus x squared is 3x squared. 16x plus 7x is 23x minus 20. All over x times x minus 1 squared times x plus 5. All right, that numerator, does it factor? 3x squared plus 23x minus 20? No? Let's just do a box real quick. It's good chance for us to review. Okay, so let's see, I have 3x squared minus 20. So you always put the x squared term there and the constant term in the lower right. And then those multiply to negative 60x squared. Factors of negative 60. 20 and 3. I could do 60 and 1, 15 and 4, 6 and 10. 5 probably, 5 and 12. 30 and 2. Okay, so I want to pick factors that add up to 23. So which set of these factors can I add and make 23?
Well, one of them has to be -23.
Yeah, because one has to be negative and one has to be positive to make negative 60, right? So 20 and 3 doesn't work because, yeah. 23, yeah, I don't think you can do it. Okay, so that doesn't factor. So that means that now we're done. I know.
If you were solving for x, you wouldn't even need to factor it, right?
You might not have to, yeah. Yeah, if you were solving for x, it wouldn't matter that that was unfactored. All right, so I know that was kind of a lot. Like I said, keep the big picture in mind. You know how to add and subtract fractions, right? You've done it for a while now. We're just doing it with a new kind of fraction. It's got letters in it, not just numbers. Okay. Lesson 29 is just a continuation of lesson 28. It's just continuing to work on adding and subtracting algebraic fractions. So I figured with 15 minutes left, I will do just an example in front, just so that everybody sort of sees one more done out, and then you can just go right back to where you left off. Okay.
So it's nothing different.
This is nothing different. Exact same thing. Nope, not even more complicated. Exact same thing. Okay, so I'm going to subtract 3 fractions here. They all have different denominators. So my first step is to factor every denominator as much as I can. So I'm going to rewrite my fractions with big lines. Not doing anything to my numerators. And then my denominators I'm going to factor. Okay. 2x plus 8. What's the GCF for 2x and 8? 2. So I'm going to pull out a 2. And then what's left when I pull out a 2 is an x plus 4. And I'm going to put parentheses around that too, because it's a factor. All right, 5x minus 15. GCF of 5x and 15 would be 5. So I've got 5 times x minus 3. And then x squared plus x minus 12, that one I have to do via a box or your favorite method. So let's see real quickly, just x squared minus 12, so I get negative 12x squared when I multiply those. And I need factors of negative 12x squared that add up to 1x. So 4x and negative 3x, because those will multiply to negative 12, and they add up to positive 1x. So I can put a 4x and a negative 3x in the box. No, positive 4 plus negative 3 is positive 1. All right, so then you look the first row of the box, you factor out the GCF, and you get an x. And you say x times what is x squared? X. And then x times what is 4x? 4. And then x times what is negative 3x? Minus 3. Okay, so that's our factorization. X plus 4 times x minus 3. Again, if you have a method other than the box that you like, it's totally okay. All right, so I have just rewritten my fractions with long fraction bars and factored denominators. Now each fraction is going to look at the other and collect what it doesn't have, right? It covets any factors that are in other fractions that it doesn't have. So this first fraction's got a 2 and an x plus 4. Looking at its neighbor, right? What does its neighbor have that it doesn't have? An x minus 3 and a 5. So if you multiply the bottom, you also have to multiply the top. Now we move to the second fraction and we say, okay, second fraction looks at its neighbor to the left, right? And what does the first fraction have that the second fraction doesn't have? A 2 and an x plus 4. And now the third fraction looks at the other two fractions. They have the same denominator now, right? And it already has an x plus 4 and an x minus 3. So what does it need? A 5 and a 2. Okay. Now I just do out all the arithmetic. So this is going to become, my denominator is 2, x plus 4, x minus 3, and a 5. And I'll just leave it factored like that. And then I'm going to simplify each of these numerators. And because I'm dealing with subtraction between my fractions, I'm just going to make sure I put parentheses so I don't forget to distribute those negative signs. So this is going to become, see, I think maybe I'll just write it all out. So this is 3 times 5 is 15. 2 times 2 is 4. And here, 2 times 5 times 2 is 10.
Cancel out the x minus 3.
You cannot cancel anything yet. Why not? You can only cancel if the only thing separating your the things you want to cancel is multiplication, right? So this x minus 3 can't be canceled because it's separated from the next stuff by subtraction. Yeah.
Isn't it minus 20?
2 times 5 times 2 is 20, yes. Thank you. So yeah, I don't want to do any canceling until I've completely multiplied everything out on top, combined like terms, and then factored. Okay, so there's several steps before I can cancel. So I distribute my 15 and I get 15x minus 45. Distribute a negative 4 and I get negative 4x. Negative 4 times positive 4 is minus 16. And then I have minus 20 all over 2 times x plus 4 times x minus 3 times 5. Combine like terms on the top. So I have, for x's, I have 15x minus 4x, so that's 11x. And then for constant terms, negative 45 minus 16 minus 20. So negative 55, negative 61, negative 81. Somebody double check that with a calculator. And that's all over 2 times x plus 4 times x minus 3 times 5. Sure, you can do that if you want. Yeah.
So, but
Either would be fine. Yep. The only thing, you should look at the numerator, 11x minus 81, and you should ask yourself, does that factor? Does 11 and 81 have any common factors? No. Okay, so that means we're done. All right, so like I said, this is exactly what you were just working on, so you can just go right back to where you were, pick up where you left off before I came up here. And we're going to be working on this for the start of next class also. So